Hi students, let's look at this question here, which is on the application of differentiation. So a man 1.8 meters tall is walking at a constant rate of 1.25 meters away from a lamppost which is 8 meters tall. 8 meters tall is very tall. I think it's a bit too tall because a lamppost, a typical story tall is 3 meters, so 8 meters means it's 2-story tall. It's possible, but very rare. How fast is the length of his shadow changing? Okay, I think there are a few things we need to assume. There are a few assumptions before we will need to start, because I think the question is not clear. First of all, man is walking on a horizontal ground. Okay, because if this assumption is not made, then we can't really, we need a lot more trigo and stuff to solve. The other one is that the lamppost is upright with respect to the ground or perpendicular to the ground. Okay, before we can even start solving this. Now let's try and understand the question here. The question is essentially, if there's a ground here, there's a lamppost and there's a man. So there's a lamppost which is here 8 meters tall, and there's a man here. Okay, so we have got a lamppost. This is a lamppost. And also the light source is right at the top, at the tip there. Okay, like I said, this question is not very clear, but we just make do with what we have. So 8 meters tall. After which, this is a man here, which is like let's see, is he's walking which is actually 1.8 meters tall, right? Yeah, 1.8 meters tall. Then we need to label all the variables away. So we know that the light source would be something like that, and the shadow would be here. The length of the shadow is somewhere around here. Okay, so this is the shadow here. This with the shadow. The question now is, if he walks away, so the walking away part is here. This is x, right? This is increasing at this rate here. So this, let x be the distance. Let x be distance of man to lamppost. Okay, we will have this is 1.25 meter, means this is increasing. So dx dt is increasing at this rate, 25 meter per second. And then let s be the length of shadow. Okay, so this is s. So now we need to find ds dt. That is the question there. It's not easy because the diagram is not drawn for you, but it is also not impossible to solve it. So I think what we need to do is use what do you call it, the similar triangle. So from diagram we know that by similar triangle 1.8, so 8 over 1.8, so 8 divided by 1.8 is equals to, because it's similar triangle, right? So 8 over 1.8 is x plus s over s. Okay, properties of similar triangle. That's what we do. Now, why do we need to do this? Because there are two variables here. This is s and x, and then using this, we can actually connect both of them, right? So usually step 1 is identify the two variables, and then step number 2 is find an equation to relate both of the variables, and this is the step here. So once we're done really, what I need to do is actually just make, so dsdt, because I need to find dsdt, right? dsdt using chain rule, this is ds something dt. So I know very clearly what I need is dx here, because I already have dx dt. So I need to find s in terms of x, right? S. So I make s a subject. This is 8 divided by 1.8. That will be 40 over 9. I just key in calculator. This is s plus s. So then 40 over 9 minus 1 will be 40 over 9s minus s equals to x. That will be 31 over 9s equals to x. Okay, great. So in other words, s is equals to 9 over 31x. So ds dx it will just be 9 over 31. All right. So this case here, ds dt is 9 over 31 using this similar triangle. So this is 9 over 31. dx dt is 1.25. All right, there you go. So 9 over 31 times 1.25. That will be 45 over 124 meter per second. So that's how we do this question here proficiently. If you have any questions at all, please let us know and I'll see you in the next question.